Introducing the University of Central Florida's Pro-E project, including the following members of Daniel Fenton, Brian Villalobos, myself, Nolen Gerke, and also Tanya Emmons. This was a project modeling the Traxxas Pro 0.15cc Nitro RC car motor, including the program Pro-E and its static, dynamic, and kinematic data acquisitions. Just to start off, a little background for the Traxxas Pro 0.15 motor. It's slightly larger than the previous edition. It's made up of several different components, runs on a nitromethane mix that could be locally purchased, happens to have electric start on this particular model, as well as glow plug style ignition. The purpose to this project was to model these parts accurately after breaking the motor down, assembling the parts into Pro-E. We animated them just to show that we could, I suppose, and then added kinematic and dynamic as well as stress analysis on the piston and crank rod. We also performed a mass property analysis, which involved us weighing the parts and comparing those weights to those that Pro-E gave us based on assumed material compositions of each part. Rather than visual inspection of the parts, our group decided to use a set of Mitutoyo calipers to accurately measure each part individually, as best we could anyhow, and entered those points into Pro-E. In the spirit of accuracy, our group also modeled all the individual parts, including screws, the head gasket, components such as washers and lock washers, as well as clutch components, and even the starter motor. These parts were purely cosmetic. We only chose to model these parts to better show the motor fully assembled. After the parts were assembled, we added Servo, which is a driving motor in the CAD world, in order to rotate the motor at a certain speed, at which point we developed a center of gravity for the piston and had Pro-E record data points as to what sort of stresses, accelerations, and velocities we were getting at the wrist pin or the top of the piston rod. We had previously confined the piston to the cylinder, so when we applied the servo motor to the crankshaft axis, it was able to drive the piston as it would in the motor effortlessly. Our group performed velocity and acceleration analysis on the piston rod, which generated graphs as expected. We also recorded the reaction at the rod as to the forces it was undergoing here in this slide. Out of curiosity, our group weighed each part individually on an electronic scale. We then compared those weights to the weights that Pro-E gave us based on assumed material compositions of each part. The results were relatively close, with about a 7% error. Some parts were more off than others, so our data is not entirely as accurate as 7%, but it was very impressive. The areas of stress that we located during our static analysis in both tension and compression of the piston rod indicated high areas of stress within the bore of the base of the crank rod. During our research of this motor, we found that a common area prone to failure happens to be the base of the piston's crank rod, as shown in this picture. This gave us confidence in our data analysis. In conclusion, this project showed us how to accurately model in Pro E, as well as use some of the tools that Pro E has to offer. Thank you for listening, and please leave any comments.